So what will be root of 1 minus cos t upon 1 plus cos t? When we put r square equal to cos t in this equation, it will be root of 1 minus cos t upon 1 plus cos t. What is 1 plus cos t? So this term will be 1 minus cos t is nothing but 2 sine square t by 2, because cos 2t is 1 minus 2 sine square t. So when we take minus 2 sine square t here and we take cos 2t here, we will get 2 sine square t equal to 1 minus cos 2t. So here if you see here, if we have angle t, then in cos it is 2t. Okay, so that is the twice of angle of sine t. So here we have t, so 1 minus cos t will be 2 sine square t by 2, half of the angle of cos. Okay, so root of this term. Similarly, 1 plus cos t is nothing but 2 cos square t by 2. So this equation will be 2 and 2 will get cancelled, and root of sine square t by 2 upon cos square t by 2 will be nothing but tan square t by 2, and root of this term will be tan t by 2. Okay, so here we get r is going from 0 to 1, and this term is nothing but tan t by 2 r dr is minus half sine t dt. Here the limits will not be r because we have changed our variable from r to t, so our limits of integration will also get changed. Here we write initial variable which is r, new variable is t. R is going from 0 to 1. When we put r equal to 0 here, what is cos of t equal to 0? When cos t is equal to 0, when t is pi by 2. When we put r equal to 1 here, cos of t is 1. At what angle cos of t is 1? At cos 0 it will be 1, so t will be 0. So these are the new limits, that is t is going from pi by 2 to 0. Now we can take this negative sign inside this integration, so the integration limit will get swapped. So pi by 2, this pi by 2 will remain as it is. Integration of t equal to 0 to pi by 2, and this tan t by 2 we can write it as sin t by 2 upon cos t by 2 instead of this term, and this half we are taking outside, so pi by 4. Sin t, what is sin 2t? Sin 2t is 2 sin t cos t. Sin 2t, that is 2 times the angle, we can write in terms of sine of single angle, cos of single angle. Similarly, sin t will be 2 sine half of the angle, that is t by 2 cos of t by 2. So instead of this sin t, we can write this term, that is 2 sin t by 2 cos t by 2. So 1 cos t by 2 from here and here will get cancelled, and we will get 2 sin t by 2 square. So 2 into sin square t by 2 dt. This is now our new integration. So t is going from 0 to pi by 2 sin square t by 2, and here we have 2, so we will write 2 here dt. So 2 1s are 2, 2 2s are 4, so here we get pi by 2. Integration of t is going from 0 to pi by 2, and here again we are going to apply the formula of sin square t by 2. Sin square t by 2 is a very complex integration, so we just cannot solve this as it is. So we know that cos of 2t is 1 minus 2 sin square t. Then cos of t will be, this t is half of this angle. So cos t will be 1 minus 2 sin square t by 2, that is half of this angle. So what is 2 sin square t by 2? In that case, we will take this sin square t by 2 here and cos t here. We will get 2 sin square t by 2 equal to 1 minus cos t. I will take this half in the denominator. I will get sin square t by 2 as half 1 minus cos t. So instead of sin square t, we can write as half 1 minus cos t dt. Now if you see, this is a very simple integration. Here we get pi by 4. Integration of 1 is t, and integration of cos is sin t, and here we apply the limits of integration. So here we have pi by 4, then upper limit minus lower limit. When we put t equal to pi by 2, here we get pi by 2 minus sine of pi by 2. Sine of pi by 2 is 1. When we put t equal to 0, this term will become 0. When we put t equal to 0 here, it will be sine of 0, which is 0. So this entire term will be 0 for lower limit. So we get pi by 4 into pi by 2 minus 1. If we take the LCM and we solve this, we get pi minus pi by 2 upon 8. So this is our final answer. So this is how we solve the problem on type 2b, that is integration over a given area using polar coordinates. More such problems we will see in our next video, so stay tuned for our future lectures.